Hi everybody, my name is Taylor Hamlin, and today we're going to talk about the concept of how day and night is a predictable pattern. And we already know that day and night is a predictable pattern because we know it's going to happen every day, and we know it's going to happen the day after and the day after. But why does this happen every single day? So to figure out the why in this scenario, let's first talk about the components that go into it. So the first thing is Earth, because that's the planet that we live on. So this is why we are curious about this, because it happens to us every single day. So the Earth is made up of land and water, and here's a globe. If you have one in your classroom, go and look at it, find where you are at the map. I'm going to find where we are right now. So we're in the United States. I specifically am in Idaho, and then I'm sure a lot of you watching are probably in Florida. So now that we know where we are, what planet we live on, our planet is the third planet from the sun, and the sun plays a crucial role in the whole day and night phenomenon. So here is a model of a sun. Now the sun is much bigger, so let's talk about what the sun is. So it's a huge ball of super hot gas. And so we're 3 planets away from the sun, and think about how hot it can get during the summer. We get up into the hundreds, and that's pretty hot for being the 3rd planet away. So just imagine how, because it says super hot, so it is very hot, and also too, it is a ginormous star, and we'll talk about what a star is in a second, but it is a ginormous star. You could actually fit 1.3 million Earths into the sun. So when you think it's big, think it's 10 times bigger. That's how big the sun is. And this isn't very fit to scale, but we're like 3 planets away from it. So that is our sun. And since we talk about how the sun is considered a star, let's talk about what a star actually is. A star is a giant sphere of super hot gas. Well, if we think back to what a sun is just a huge ball of super hot gas. So the sun is one of the biggest stars in our solar system, and it's made up of super hot gas, which classifies it as a star. So now let's think back to like the little stars that you might see out in the night sky. Even though they appear little to us, they're actually pretty large and we can see them. So a group of visible stars is called a constellation. Now, you may have heard of a constellation before. You may think of those mythological creatures, and you may think of the Little Dipper and the Big Dipper. But those are correct. Those are constellations because they are a group of visible stars. And now, although we may be able to see some stars during the day if they're really bright, like the sun, we can see the sun during the day. But usually, constellations are seen at night. So since we were talking about nighttime in the night sky, one main thing that I think of is the moon. So let's talk about what the moon is. The moon is a dusty ball of rock, and the moon is pretty small. So let me pull out my moon here. So here is our moon. It's just a pale gray kind of color, and because it's a dusty ball of rock, you may have seen pictures before. They have craters on it, and this orbits around Earth. So, orbit, down here, it means to travel around. So here I have Earth, here I have our moon. So the moon is going to be traveling around our Earth. It's orbiting around our Earth. So, orbits or travel around, whichever you want to say it, but just know that our moon is moving around our Earth. So now, back to our concept, we're talking about predictable patterns. So our Earth, our moon, and our sun have predictable patterns of movement. And so we've already kind of talked about the moon's pattern. It just orbits around our Earth. And the sun is the core of our solar system. So everything, if it's going to move, it's going to move around our sun because our sun is like it's the middle of our solar system. So let's talk about the Earth's major movements. So the first major movement is Earth rotates on its own axis. So here is Earth. So an axis, in case you didn't know, is like if I had a pole, if my finger was a pole, it's going to go to the bottom, through the middle of the Earth, and out the top here. And now the Earth can rotate on that pole. So that's what the Earth is doing. But there's really not a pole, it's just an imaginary thing. But also, our Earth is tilted 23.5 degrees. So we are spinning like this. And we're spinning every single day, every minute, even if you don't feel like you're moving, our Earth is moving. So here we go. So one rotation, so once around, equals 24 hours, and 24 hours equals 1 day. So here, let's look at the United States. We're going to spin around until we get back. And we're right there. So that would equal 1 day. So the next major movement is Earth revolves around the sun. So here is our sun, and to revolve means you're going around. So we're going to be going around the Earth. And that is every day too. And one revolution, so one going around, equals 365 days. 365 days equals a year. So now you know why. Like, why isn't it just 100 days? Well, because 100 days, we wouldn't fully be around the sun. So 365 days means we went around the sun one time, which makes sense. But also remember that while we are going around our sun, we are also, oops, I have my earth all messed up. We're also spinning as we're going around. I don't know how we're not dizzy. So, we know the moon's going around our Earth. We know the Earth is rotating on its axis, which is that imaginary pole. And we also know that our Earth is going around our sun. So now, using all that information, we are going to now model day and night. And how we are going to do this, I'm going to represent the sun using a flashlight. I'm going to take the Earth, say this is the sun pointing, since we go around the Earth, and we're spinning. So we start over here. If you look over here, Florida has light, but I'm in Idaho, and it doesn't have light. But as we spin and move around, now I have light, and Florida doesn't. But then it would continue to go around. So, and also if you think about it, if I shine it on China, it's daytime in China, but if we spin it around so you can see, in the United States, it's dark, there's no sun, so this would mean that it'd be nighttime. Same thing, let's go here in Africa. Over here in Africa, it is daytime, but if we spin it around and look exactly what's behind it, oh, water, but the United States would still be nighttime. And so as you go around, it'll be different day and night times in different parts of the world. We may all still live on the same planet, but it will be daytime in different parts and nighttime in different parts. Just depends on where we are in our rotation and where the sun is at. I hope this helps you out, and have a great day. So while we're learning about the Earth, the Sun, and the Moon, you guys may have some misconceptions about these concepts. So the first misconception that is common is Earth is the center of the solar system. In the video, we talked about how the Sun is actually the center of the solar system. So this means that Earth and all the other planets are actually revolving around the Sun. The next misconception that's common is the reason we have night is because our moon is covering up our sun. The reason why we have night is because our Earth is rotating on its axis, and when it's turned away from the sun, depending on where you're at on Earth, you will have nighttime and it will be dark. The next misconception that's common is Earth goes around the sun in 1 day. The Earth rotates in one day, but the Earth going around the Sun is actually one whole year, 365 days. And the last misconception is stars appear in the same spot every night. So if you look at constellations, they're not always going to be in the sky all the time. They're going to change throughout the year because our Earth is rotating and revolving, and we're going to see different parts of our night sky. So for the first link that is posted, the Science Kids one, you'll first have to choose how many months it takes for the Earth to revolve around the Sun. And there's going to be a video and it will show you. So I chose 6 months the first time, and when it rotated, it only got halfway around the Sun, so I had to try again. And you'll be able to visually see this. After you figure out how many months it takes to revolve around the Sun exactly one time, then you will be able to experiment with hours, days, weeks, or months to see how far the Earth moves around the Sun and how the Moon revolves around the Earth. Then while you're doing that, I think you should compare how far does the Earth move one day versus 1 week, and talk about the similarities and differences. The second link is a video simulation of what Earth looks like while it is rotating on its axis. It shows how half of the world is lit up and how the other half is dark because it is rotating away from the Sun. You can also see a time of when it's rotating, so you can see when it's day versus night. And you can also see how the Earth isn't sitting perfectly straight, it's tilted on its axis.